Philosophers say a lot of silly things, or why you should get a degree in philosophy. Let's face it, a lot of the stuff that gets covered in philosophy classes is pointless and even downright silly. For example, I start my Philosophy 101 classes with excerpts from the pre-Socratic Greek philosopher Thales, widely regarded as a pivotal figure in the origins of Western philosophy. But Thales makes some ridiculous claims, like, the source of all physical things, and that into which they will return, and that of which they are made, is water. The earth rests on water. Earthquakes, whirlwinds, and the movements of stars are all the result of water undergoing state changes. The sun and stars glow because they're on fire, and the very fire of the sun and the stars is fed by exhalations from the waters. Magnets have souls. Thales was big on water, obviously, but these are some pretty wild claims, right? Well, not so fast. Not so fast. Thales held that the first principle of everything is water, and his reasoning was actually pretty impressive. Basically, his idea is that all things in the physical world are made of water that has undergone various state changes. And that's a brilliant idea, since water is the only substance that naturally exists as a solid, a liquid, and a gas in ordinary experience. Thales didn't know about other states than these three, of course. But if water can be a solid, a liquid, and a gas in ordinary experience, then why can't it also be fire, or earth, or wood, metal, cheese, and wine, and everything else? And once we concede that everything is water, the idea that things like earthquakes, whirlwinds, the stars' movements, and the sun's heat are all caused by water undergoing a state change actually makes a kind of sense. So even if all we knew about Thales was that he claimed that water is the first principle of all things and explains all physical phenomena, even though he was wrong, he'd still be justly honored as one of humanity's towering geniuses. But interestingly, he made a number of other claims, some of which are not only more plausible, but are actually true. These include, the moon is made of earth, really solid water, and is not on fire like the sun and stars, but merely reflects the fire of the sun. The moon travels with the sun, as is shown by lunar phases. A solar eclipse is just the moon getting in front of the sun, and a lunar eclipse is just the earth casting a shadow on the moon. The earth is spherical in shape, and winds can affect the depth of water in a river like the Nile by pushing it and piling the water up. Philosophers in the millennia following Thales have likewise made a number of very silly claims. René Descartes, for example, thought that light rays impressed tiny little bits of matter onto our retinas, forming an image, which is then transmitted to the pineal gland. The pineal gland is the bridge between our physical bodies and our souls in Descartes' theory. Kind of silly. Or consider the brain in a vat thought experiment. It's very easy to state and utterly nuts. It says, prove that you're not a brain in a vat. That is, imagine that some technologically advanced scientists have transplanted your brain into a vat and hooked you up to a computer that feeds your senses. How could you tell right now whether or not this is true? The computer would be feeding you experiences that are just like those you'd experience from any real reality, and any glitches in the program could easily be explained away as just the way the actual world works. I mean, that's a fun thought experiment, but it's pretty silly, and what's the value of something like that? Even philosophers themselves have at times realized that they look pretty silly. Protestant Christian philosophers in the late 1600s, for example, mocked their Catholic peers by attributing to the latter such silly questions as, how many angels can dance on the head of a pin? The Protestant philosophers were mainly mocking St. Thomas Aquinas, who never asked quite that question, but did ask, can several angels be in the same place? Which is also kind of a silly question to ask, if we're being honest. To make matters even worse, when philosophers do come up with a good answer to some question or other, that thing tends to exit from philosophy and become its own discipline. In this sense, philosophers have been in the process of putting themselves out of business, albeit very slowly, for millennia. And here's an interesting bit of trivia. There are more professional philosophers in the world today than there have ever been at any point in history. I'm not sure what that says about modern society, but it does seem to indicate that trying to put yourself out of business is not a bad business plan. So anyway, if the study of philosophy is partly the study of silly ideas that people came up with a long time ago, which is really what it is, what's the point of it? Philosophy departments are in fact being shut down all over the place right now as I write this. Philosophers are losing their jobs, degree programs are being eliminated, and college students are being guided to more lucrative professions. That's a good thing, right? Well, it depends on what skills and behavioral dispositions you want your college graduates to have. We can make a distinction in every profession and every field of study between what we can call processes and what we can call facts. Let me use mathematics here as a discipline to illustrate the difference. Most people coming out of high school and entering college probably think of mathematics as a bunch of math facts. That's the exact term used by my kids' K-12 math teachers, by the way, math facts. What counts as a math fact? Well, if asked, I suspect that most of those people just entering college right now would say that it includes basic facts about addition, subtraction, multiplication, and division, plus maybe some vague ideas about algebra and geometry. Oh, and PEMDAS. A surprising number of rising college freshmen will get really excited about PEMDAS, which is an acronym that specifies an order of operations. But significantly, nearly none of those students will understand the concept of an order of operations more generally, or will know that there are ways of specifying orders of operation without recourse to PEMDAS. I say this because we actually talk about order of operations in my Introduction to Formal Logic classes, and the system we learn has no PEMDAS equivalent. Order is entirely indicated by parentheses. To put this all a little bit more elegantly, for most new college students, knowing mathematics is synonymous with being adept at manipulating symbols and following memorized step-by-step procedures. Based on these experiences, many teachers of mathematics learn to view mathematics as a discipline with a priori rules and procedures that students merely have to learn by rote. And that's a quote from a paper by Weiss and Moore-Rousseau called Thinking Like a Mathematician, published in Mathematics Teacher in 2012. Anyway, the question I have, and this is a question for any mathematician out there, is, does such a student who thinks about math entirely in terms of math facts and memorized procedures really understand what mathematics is about? And I'm pretty sure that all of my mathematician friends are going to say, nope, that student doesn't get mathematics. That student is not thinking like a mathematician. What does it mean to think like a mathematician anyway? Again, quoting from Weiss and Moore-Rousseau, mathematicians strive to generate new and refine existing mathematical ideas and methods through flexible thinking. That is, doing mathematics is a process of discovery, not a static state of knowledge. The same is true of formal logic, which philosophers teach, and this is probably not surprising since formal logic is mathematical in nature. And college students in logic classes usually have the same misconception of logic that they do of mathematics. Such students generally think that the pre-digested logical systems with which they are presented are it, and that logic is just a matter of learning those systems, a lot like learning the rules of canasta or some other card game. That's not doing logic, however. Doing logic is a creative activity in which one tries, to borrow some language from my mathematical friends, in which one tries to discover new and refine existing logical ideas and methods. Philosophy in general is no different than mathematics. It's both fun and useful to learn about what other philosophers have come up with already. And if you learn enough of that stuff, you can even get a job as a college professor of philosophy. But none of that is doing philosophy. The heart of philosophy is the creative process of generating new and refining existing philosophical ideas and methods. So in this sense, philosophy is a lot like mathematics, and as I expect you have already concluded, a lot like every other discipline out there, since every discipline at its core is about discovery, not merely about passing on facts that have already been established. But philosophy differs from all other disciplines in one very important way. There are no philosophical facts, not in the sense that there are math facts or facts about chemistry, biology, psychology, economics, or even literature. As I have already noted, whenever philosophers discover something that achieves consensus as a fact, it goes off and becomes its own discipline. So what then is the value of philosophy, since we're not really in the business of, discovering philosophical facts? The heart of philosophy, and that which makes it worth studying, is the creative process of discovery itself. Philosophers identify, define, and clarify questions, and then explore possible methods for answering those questions along with possible answers to them. I think that most artists will say that their understanding of the creative process and of art deepens as they practice it. Philosophy is the same. It's an art in just this sense. Philosophy as a creative process isn't something that's easily taught, of course, any more than teaching any art is, but your philosophical abilities can be developed through a study of philosophy, or the history of philosophy, really. That is, don't study philosophy expecting to find correct answers, although you'll find that a lot of answers have been offered for nearly all philosophical questions, and there's a good chance that at least some of them are correct. We just have to figure out which. No, rather, study the thought processes that resulted in asking those philosophical questions in the first place, and then study the thought processes that resulted in all of those answers. That's the important stuff in philosophy. For example, ask yourself, why did Thales start wondering about possible naturalistic explanations for physical phenomena? After all, the worldview found in Homer certainly explained everything. It's all just down to the gods. And then once you figured out why Thales started wondering about possible naturalistic explanations for things, after that, ask yourself, how did he come up with the idea that everything is water? That is, how did he come up with the specific ideas that he came up with? And when you ask yourself these questions, try putting yourself in Thales' shoes, or sandals as the case may be. Pretend that you know nothing about the physical world. Pretend that modern science doesn't exist. Be Thales, watching the tides, watching the stars, examining magnets, and so on. His answers may or may not have been silly, but the philosophical approach, which is common to all disciplines, it's right there in what Thales was doing, and it's not silly. If there's a sense in which everyone's a philosopher, no matter what their field of study or what their profession is, it's in this universal creative process that really is the heart of every discipline, but which is especially well expressed in philosophy.